Hello, students. Welcome. Today we are going to be covering section 12.1. It's known as Everyday Stiochiometry. So we are starting a new chapter, a new topic. Okay. Remember, all of this comes from your CK12 packet. How much equipment do you need for an experiment? Okay. And stoichiometry is one of the hardest topics that we're going to cover other than balancing. But remember, we said balancing was hard, but now you guys are balancing like nobody's business. So it is possible to get good at balancing. So it is possible for you to get good at stoichiometry. Just because I said it's hard does not mean we give up. Okay. So we are going to start that today. We're going to start by talking about equipment on experiment days. Who's going to help?
How much equipment do you need for an experiment? You are in charge of setting up the lab equipment for a chemistry experiment. If you have 20, 20 students in the lab and they will be working in teams of two, and the experiment calls for three beakers and two test tubes. How much plasma do you need to set up? Figuring this out involves a collective balance equation and the sort of calculations you do for a chemical reaction.
Thank you, Miss Alexia. So, if you're doing an experiment, and this always happens, this happens in class actually. So, most of the time, if I have like a 30 student class, it's like 20 to 25 students show up every day. But as soon as people start talking, hey, did you hear? We're going to do an experiment in class today. Hey, did you hear? Ms. Fernandez said we're going to do a lab. Hey, we did a lab in first period. You need to go. Dude, by the time I know it, all 30 students are there. And I'm like, oh man, I had only prepared for 6 groups, not for 8. So there I go back into the storage room to go get more equipment because I thought that I was only going to have about 20 to 25 students. Now all of a sudden I have 30 some students because everybody heard that we're doing a lab and they heard it's fun, so they show up. It always happens. So if I have 20 students, right? I was supposed to have 20. All of a sudden, I got 30, and they're going to be working in teams of 2. Well, that's 15 groups, and I need 3 beakers for each group. So 15 times 3, what is that? 30, 45 beakers. It's that 15 groups times 2 test tubes. That's 30 beakers. So there I go back to the storage room to go and find beakers and test tubes. And you got to remember, students break those things all the time. So beakers can sometimes be hard to find. But it's fun. I like doing lab. I love the fact that you guys love doing lab. And it's one of the best times we have in class. So it's really disappointing that we're not in school, that I can't do some of the fun labs that we do every year. But you can't control the pandemic, right? You can't control COVID. So we're stuck here online. So everyday stoichiometry, you have learned about chemical equations and the techniques used in order to balance them. Chemists use balance equations to allow them to manipulate chemical reactions in a quantitative manner. So, okay, if I have 100 grams of hydrogen, how many grams of water will I make? So I need an equation where I'm changing hydrogen and oxygen to water, and then I need to balance it, and then I need to change grams to moles of hydrogen. Then I need to change moles of hydrogen to moles of water. So I'm going to need a reaction. I'm going to need to use the equation, and then I can change moles of water to grams of water because I know how to do that, right? Today, we're going to learn the basics on how to do this. We're going to learn the basics on how to use equations to answer different questions. And we're going to talk about this beautiful ham sandwich that you see in front of you. I see it every period. I've seen it every period. This is the fourth time I've seen it, and it keeps looking better and better. Mostly because isn't lunch coming up? Okay, so if I have this beautiful ham sandwich and it's made up or composed of 2 slices of ham, H, 1 slice of cheese, C, 1 slice of tomato, T, 5 pickles, P, and 2 slices of bread, B. I need to create an equation. Okay, so I'm going to use the information I know, and I'm going to create an equation, a reaction, right? And it's going to balance itself um, in a very easy way, so we don't have to worry about balancing. Don't worry, everything's going to be accounted for. Okay, so the first thing we need to start off with is ham. I know it's going to be represented by the letter H. And since I have 2 of them, I'm going to put a coefficient in front of H. And you can see it here, right? You can see the H for ham. You can see the 2 for, because I have 2 slices. Now, when it comes to cheese, I have to put the letter C, but I only have 1. And we don't show ones in reactions, so I'm just going to put capital C. Pickles. I'm sorry. Did I say tomatoes? There's only 1 slice, so we just put the T for tomato. Pickles, the letter P. I got 5 of them, so what's the number in front? 5. B for bread. There's 2 of them, so what's my coefficient for that? 2. And then it's gonna yield the whole sandwich. So I'm gonna put it all together in one sandwich. So all of a sudden, all of the individual ingredients are gonna come together and make one large compound or one large sandwich. Now, the coefficients are gonna change. The coefficients are gonna become subscripts for that ingredient. So for ham, since I have 2 slices, I'm going to put a subscript of 2. Cheese, I only have 1. You can't see the imaginary 1, but it's there. Tomato, the same thing. There's an imaginary 1. And then I have pickles. Pickles. So I got 5 of them, so my subscript is going to be 5, right? My coefficient is now my subscript. For bread, my coefficient was 2. What's my subscript? 2. And you have a balanced chemical equation or a balanced ham sandwich equation, right? It's not really a chemical equation. So it's all about this ham sandwich. Does everybody see how we did this? Okay. Now I want you to try it out. You are to use the table of ingredients below and write an equation for the sandwich in the picture. All right, so go. I believe I had 5 students or 4 students in Pear Deck. I want all 4 or 5 of you guys to try and write this equation. All right, so let's see. Who's going to start us off? Okay, yeah, B2. Very good. What about the cucumbers? C. Okay, remember, it's a coefficient. We don't put coefficients in the back. Where do coefficients go? Anybody? Where did coefficients go? Don't they go in front, Oscar? Yeah, they go in front of the... Right, they go in front. Very good. Hey, Irvin, Kevin. I don't think I changed Irvin. Okay, so... Oh, I didn't take attendance. Diamond, Alexia, Caitlin, Efrain, Mario, Jose, Kevin, Irvin, Oscar, and I don't see anybody else. 1, 2, 3, 4, 5, 9 students. Do I have 9 students? Jeremiah, because he's on another page. Yes, I got 9. Okay, but if I'm going to write it into an equation like the one they showed us, shouldn't I write it sideways? Remember, guys, you need to write it sideways. You need to write it like a reaction. So I should have that 2B, that 3O, the 2T over here in a straight line. I know Irvin wants to try it. So there's the link, Mr. Irvin. Jeremiah's here. Mm-hmm. Very good. This is what I want. I want it to look in the form of an equation. But don't forget, the coefficient for the bread should be in front, not behind. Very good. Okay, so she started writing, or he started writing, that we have 2B, 5C, plus, remember, 2B, not B2. 2B as in boy. The 2 needs to go in front of the letter B. That's the only thing I see wrong. Okay, B as in boy, plus 5C, plus 3O, plus 2T, plus, there we go, there we go. Very good. That looks good. Plus A, arrow. Oh no, plus, yeah, okay. So the 3, very good. Arrow. And now you need to put all the letters, right? But I need a formula. I need a compound. So you're going to put B as in boy. And I would write this with a marker or whatever it is they give you, the tool. And I know it's going to look not the prettiest, but it's okay. So let's write B as in boy. Let's write B as in boy. And let's change the coefficient into a subscript. So you're going to put B, you're going to put a little 2 on bottom, and then your cucumbers, you got 5 of them. My subscript, very good. O for onions, very good. Keep going, keep going. Start writing the equation, put all those letters together, put those letters together. Remember, you're going to put the elements, right? The ingredients first. And then the numbers are going to be subscripts, just the way you see it here. Very good. This is my compound. I have B, subscript 2. Cucumbers, subscript 5. Onions, subscript 3. Tomato, subscript 2. Avocado is a 1. And my ham, I have 3 slices. Very good. That's perfect. That's exactly what you need. Okay, we're going to need this for the next Pear Deck question. Very good. Very good. 3 students did this. Excellent. Let them finish writing and then we'll move on. Are you guys done writing or you're not going to finish writing? ¿Qué pasa? Okay, they're continuing. Finish the compound so that we can move on. Finish the compound. And this looks like a really good sandwich, doesn't it? Doesn't it look like a really good sandwich? Can somebody just like bring me the sandwich? I don't want to make it. I just want to eat it. The only thing I would have taken off was the onions. Other than that, it looks delicious. It's got cucumber. It's got avocado. Hopefully there's some ham in there. Could totally use that sandwich right now. Very good. Okay, excellent. All right, let's move on. Now let us suppose you are having some friends over. Okay, so Oscar, right? So no cucumbers for Oscar. Okay, so Oscar invited his friends over. And of course, they're waiting outside, right? Because of the whole pandemic thing. They're waiting in the backyard or in the garage, waiting for Oscar to come. Because Oscar said, "Hey, you guys hungry? I got some ham. I'm going to go make some sandwiches. Anybody want one? And all his friends are like, yeah, I'm hungry, right? Students are always hungry. So over there, so Oscar goes inside and he checks out and he looks and sees, okay, do I have enough for all 5 sandwiches, right? So how much of each ingredient do you need? Would you take the number? You would take the number of each ingredient required for one sandwich and its coefficient and multiply by 5, right? That would be the way you would try it. All right. So using the ham and cheese example, we can make a conversion factor, right? We can use the equation that they presented at the beginning of the presentation, and we can use that information to write a conversion for each ingredient. But they only did it for ham and cheese. They said if I have 5 sandwiches that Oscar needs to make, and each sandwich needs 2 slices of ham, 1 slice of cheese. Remember, all of that information, everything you see on the right over here, the 2H, the formula, the 1C, the formula, all of that comes from the equation, okay? This information didn't get pulled out of thin air. It came from the equation that they wrote for all of the ingredients earlier. Okay, and you can see it here from this guy down here. You see the 2 hams. You see the 1 slice of cheese. You see the 1 sandwich that is being made. So they're using the information from the reaction to change the sandwich, your 5 sandwiches, into slices of ham for the first one. In the second one, they're changing the sandwiches to cheese because Oscar needs to make sure that he has enough for all of him and his friends, right? He's not going to make this big old sandwich and then just put 1 slice of ham and cheese and hand it to them. No. He's going to be a nice guy and he's going to make an awesome sandwich for all of his friends. So you always start with information they gave you. They said that you need to make 5 sandwiches. Okay? So you're going to start with the 5 sandwiches and then you're going to use the information from the equation to change your sandwich to ham. One sandwich, uses 2 slices of ham. The sandwich will cancel with the sandwich and you're left in H, which is ham. And the only thing that's left to do is to run the numbers. 5 times 2, right? Remember, if they're both on top, you always multiply and then you divide by the bottom. In this case, it's a 1, so you really don't have to divide because 5 times 2 is 10. 10 divided by 1 is still 10 for the ham. If we were talking about cheese, 5 times 1 divided by 1 is 5 slices of cheese. If he doesn't have the 5 slices, somebody's going to get a sandwich without no cheese. And you can do this for every single reactant, every single ingredient in this sandwich. Okay, but I'm not going to do it. Okay, I think you can understand that. And plus, we have a sample problem coming up. The conversion factors contain the coefficient of each specific ingredient as the numerator and the formula of the sandwich as the denominator. The result is what you would expect. In order to make 5 ham sandwiches, you would need 10 slices of ham, 5 slices of cheese. This type of calculation demonstrates the use of stoichiometry. Stoichiometry is the calculation of the amount of substances in a chemical reaction from the balanced equation. The sample problem below is another The sample problem below is another stoichiometry problem involving ingredients from the ideal sandwich. So we're going to use the equation from earlier, this one. And we're going to use it to do the sample problem, which I already have on Jamboard. Don't look at the answer. All right. Here's our sample problem. We're going to change Kim to Irvin because Irvin's always hungry. Trust me. I know. I dealt with him in wrestling. Okay, so if Irvin's always hungry, Irvin is going to look in the refrigerator and find that he has 8 slices of ham. And then he notices, oh no, we need to use the ham. Why? Because it's going to expire next week or in 2 weeks. So he's like, hey, anybody want a sandwich? I'm making sandwiches and we need to use all the ham because it's going bad. And then his little brother says, I want a sandwich. And then his mom's like, I want a sandwich too, Irvin. And then his cousin or his friend says, okay, I want a sandwich too. So he needs to make as many sandwiches as possible using the equation from earlier. I'm already tired of sitting down. Okay, so it says here, how many pickles does he need? All right. So we need to first off, anytime you have a reaction or you have a problem that gives you numbers, you need to circle them. And then you need to circle, what are they asking me to change it to? Well, they're giving you 8 slices of ham and they're asking you to change your 8 slices of ham to pickles because they want to know how many pickles you need in order to use up all the ham. Okay? We can do that, right? We're going to go to the equation and we're going to figure out, okay, how much ham, how much pickles was used? Let's go back to the presentation. Here it is. How many hams does it say in the equation below? H is for ham. How many pickles? Right, 2 slices of ham. How many pickles? P is for pickles. How many pickles? 5. So I'm going to take that information, 2 hams, 5 pickles, and I'm going to take it back into Jamboard. Okay? So I know for every 2 slices of ham, I need 5 pickles. I love pickles on my sandwich, by the way. So that's my conversion, right? That's going to change my ham into pickles. But I'm going to start with what they gave me in the problem. I'm going to start with what they gave me in the problem. And what did they give me? What number? 8. 8 slices of ham. So I'm going to go ahead and I'm going to put that over 1. And the reason why I do over 1 is so that you can see, okay, if I'm going to cancel, where does H need to go in order to cancel? All right. And remember, draw the arrow. It helps you. Draw the arrow because it helps you it helps remind you where H needs to go in order to cancel. Where does H need to go in order to cancel? Top or bottom? Where does the arrow point, guys? Where's the arrow pointing? Where does H need to go? This number needs to follow the arrow down. So I'm going to put here on bottom 2H. Okay? How many pickles? Well, there's only one place pickles can go, right? There's only one place pickles can go. I don't like the highlighter one. So I'm going to put 2H on bottom, 5 pickles on top, and you can see the H cancels with the H, right? The arrow does that. It shows it to me. You can see it here. Look, it ran right through it because it's trying to remind you that ham is gone. So now we're left in pickles. Now, what are we going to do? What do we do this way? What do we do this way? What did I say we do this way? Side by side. What do we do when the numbers are side by side? We're going to multiply. And after we multiply, what am I going to do up and down? What do I do? What does this line mean?
Divide.
Very good. You will multiply 8 times 5. And whatever you get is going to get divided by what number? 2. What's my answer? 8 times 5 and then divided by 2. 8 times 5 and then divide your answer by 2. 8 times 5 divided by 2. Very good. That means Irvin needs 20 pickles. Very good. And we could probably do this for every single ingredient in my sandwich. Okay, but they don't ask me to do it, so I'm going to stop there. Okay. Now it's your turn. You can see the 8 pickles right here. All right. Now it's your turn. You're going to use the information from the reaction earlier, from the equation that we made in the first pair deck question. You're going to change 8 slices of onions because they're asking you to change them to cucumbers. How many cucumbers do you need? So you're changing your 8 slices of onion to cucumbers. All right? So I need you guys to go in there, circle the information that's provided. What's the information provided in the problem? Circle it. What's the number they give you in the problem? And circle it. Very good. 8 slices of onions. 8 slices of onions. Very good. What do they want you to change the onions to? Can you highlight that? Can you highlight what they want you to change the onions to? Oh, very good. Cucumbers. They want you to change your onions to cucumbers. Okay? So the first thing I'm going to do is I'm going to put 9 onions over 1. Show me 9 onions over 1. I'm not going to look at the reaction. I'm not going to look at the equation. I'm going to start by showing the information they gave you. 9 onions over 1, right? Perfect. Look, he's already done the setup. Now we're going to go back to the last pair deck question and we're going to see how many onions and how many cucumbers were used. Did the other person do it? Okay, set up your problem. 9 onions over 1. Set up your problem. Okay, let's go back to pair deck. Are they done writing? Okay. 9 O, right? O for onion. Very good. O for onion. You need to include the unit. You must include the unit. Or in this case, the unit, I'm not necessarily the unit, the element you're working with. The element you're working with. Because the unit would be slices. Okay, but we don't care about unit. Just put 9O. Okay, so let's go back to the last reaction. Let's look at the numbers. According to this reaction, how many onions and how many cucumbers? Can somebody write it in the chat? How many onions and how many cucumbers? How many onions and how many cucumbers? How many onions, guys? 3 onions, right? How many cucumbers? 5 cucumbers. 5C, right? 5C. Very good. And you can put that they equal each other, Oscar. You can put 3O equals, 3O equals 5 cucumbers. Okay, that's how you show your conversion. Okay, very good. Okay, so we're going to go back into the other pair deck. And we're going to use that conversion that Alexia put in the chat. We're going to use the conversion, but my question to you is, where do onions need to go? How do I cancel onions? Is it going to go on top? Where does onions need to go? Top or bottom? Yes, it goes on bottom, right? We need to cancel those onions by putting them on bottom. Very good. Right? You can cross out onions with onions. You can cross them out. They're gone. And you're going to put your 5 cucumbers in the on top, right? So onions cancel with onions, and all that's left is cucumbers. Now run the numbers. What multiply across, divide down. Multiply across, divide down. And no, I'm not doing TikTok. No TikTok. How many cucumbers? Don't just give me a number. Put in there what element, or I'm sorry, what ingredient are you dealing with? What's the ingredient? 15 what? Onions? Cucumbers. Very good. Very good. Very good. Very good. Perfect. That looks good. That looks real good. Onions, cancel with onions. And we're going to multiply 9 times 5 divided by 3. And that's going to give me 15 cucumbers. Thanks, Alexia. I knew it was you because it was all colorful. I knew it was you because it was all colorful. This is probably Miss Diamond or Oscar. Is it Diamond? Yeah. Thanks, Miss Diamond. Thanks, Alexia. I don't know where Oscar is, but he wasn't helping. All right. Thanks, ladies. So, in summary, an example of everyday stoichiometry was given. Your review questions. A smoothie contains 1 banana, B, 4 strawberries, ST, 1 container of yogurt, Y, and 3 ice cubes, IC. Write a balanced equation and to describe this relationship. Number 2, write a conversion factor to show the relationship between the number of ice cubes and the number of smoothies. How many strawberries would you need to make 12 smoothies? Everybody ready? All right. Thank you.